Good day, everyone. Thank you for joining us today for this session on detecting and diagnosing performance issues in Amazon Aurora. As most of you know by now, we launched DevOps Guru for RDS at reInvent 2021. So we'll be focusing our talk on that new capability for today. I would like to first invite Maxim to introduce himself. Maxim?
Hello, everyone. My name is Maxim Karchenko, and I'm a principal database engineer who is working on DevOps Guru and DevOps Guru for RDS.
Awesome. And my name is Shayan Sanyal. I'm a principal database specialist solutions architect, and I specialize in the Aurora Postgres engine. We are here to talk to you today about DevOps Guru for RDS. And this is a great new capability for DevOps Guru that brings in-depth machine learning to help you manage your database performance as part of the full application stack. So let's get started. Today, we are going to start out by setting some context by telling you about Amazon RDS in general, Amazon Aurora, and performance insights, which are foundational concepts and building blocks of DevOps Guru for RDS. Then we'll take some time to understand an important metric that we use called database load. We learn how it's derived and why it's important. Then we'll walk through DevOps Guru for RDS, including how to enable it, how it helps you, how it works. After that, I'm going to hand it over to my colleague Maxim, who will take you through a demo of DevOps Guru for RDS. So you can get a sense of how it can help you detect, understand, and react to performance concerns that may arise on even the best tuned databases. We'll then wrap up the session with some pricing information. Okay, so first let's level set about Amazon RDS and Amazon Aurora. As many of you already know, RDS and Aurora are what we call managed database services. In essence, they are automatically managed databases that take care of the mundane day-to-day tasks for you. These are things like provisioning a new database, scaling up and down, backup and recovery, high availability and disaster recovery, and the list goes on. Basically, everything you would be scripting yourself or doing manually on a conventional database, we automate all of that in Amazon RDS and Amazon Aurora. Now, you may ask, what is so special about Amazon Aurora as compared to Amazon RDS? Well, as you might already know, Aurora is our cloud-native database engine. We designed it to meet the needs of enterprise customers who are accustomed to the legacy commercial on-prem databases. These are customers who need powerful and full-featured databases, but are getting tired of the legacy databases' punitive licensing, their significant expenses, their lack of cloud-native capabilities, etc. So Amazon Aurora is our answer to that need. At the SQL prompt, Amazon Aurora looks and feels just like Postgres or MySQL. But behind the scenes, it features a distributed, fault-tolerant, self-healing storage system that auto-scales up to 128 terabytes per database. Each Aurora cluster replicates automatically across 3 availability zones, while at the same time delivering high performance and availability with up to 15 low latency read replicas. So in essence, Aurora is a cloud-native, massively scalable and available database. It aims to address high-end commercial and enterprise use cases in a way that MySQL and Postgres don't do by themselves. And Aurora aims to do it at a lower cost to customers than the legacy commercial databases. Now, as I've mentioned in RDS and Aurora, we want to make it easy to set up and manage databases. Well, an important part of managing databases is managing performance. Even the best tuned databases need some kind of performance help at one time or another. And being able to see and understand what's happening in your database is key. We know that relational databases have a reputation for being complex and difficult to tune. So in 2017, we introduced a dashboard called Performance Insights. Performance Insights shows you your current activity, it shows you your database metrics, and it shows you your top SQL commands, all in a simple, straightforward console screen. But the core innovation of Performance Insights is actually a single metric called database load. This metric is the key to simplifying understanding database performance. It's at the heart of Performance Insights, and it's at the heart of DevOps Guru for RDS. Now, we are just going to take a small detour to explain this DB load metric a little bit more. So what is a database load? Well, simply stated, it is a count of how many database sessions are active at any given time. Performance Insights collects this count once every second. What do I mean by a session? Simply put, a session is just a connection to the database. But we don't just count all sessions. We count all active sessions, that is, connections for which the database is in the middle of fulfilling a request. So that means we are counting sessions that are not idle, but instead active in a call. Now, it turns out, especially if you average this count over 1 minute, 5 minute, 15 minute, or 1 hour intervals, this gives us a very accurate measure of how stressed our database is. In Performance Insights, we usually show this metric in period averages. So because we are averaging the metric over periods of time, the unit of measure we use for database load is called average active sessions, or AAS in short. In essence, DB load is RDS and Aurora's central metric for measuring performance health. We at Amazon have found it to be the metric that's the most reflective of service quality from the customer perspective. Just to dive deeper for a minute, I want to show you exactly how we derive this metric from your database activity. As we mentioned, a session is a connection. Here's a connection, connection 1, and here is the connection making a request to the database. Down below here, we have a 20-second timeline just for illustration purposes. But databases and database connections don't usually just make one request. They make many such requests in succession. And this is just one connection. There may be many such connections from many applications to any given database. And each connection may fulfill many different requests. And these requests will likely have a variety of durations. So what Performance Insights does is it comes in and it samples the number of active sessions once a second. So if we take a look at just the first sample here, from the top, there is 1, 2, 3, 4, 5 active sessions at the time of the sample. Similarly, if I went ahead and counted all of these and just put the sum below, you will see this is what we get is a count of each sample per session. As you can see, this is what produces our database load metric. It's that simple. It's just a simple count. So that's database load in its most basic form. But now I want to show you something interesting. During a database request, a database does all kinds of things. It might spend some of this request time doing reads and writes, and it might spend some of this time waiting on locks and so on. It seems like this metric and our sampling offers an opportunity not only to show how many requests are being handled at a time, but also to show you what those requests are doing. Now, because every active database request is doing something at every given moment in time, like running on CPU, reading from disk, or something else, Now I want to introduce this concept called wait events. Most modern databases are instrumented with what are called wait events. And these wait events are just names or labels for what a request is doing at any given time. And this illustration here is a bit of a simplified version, but each of these colors represents a different wait state or a wait event in an imaginary database. Now, real databases like Postgres, MySQL, Oracle, or SQL Server all have different names for their dozens of various wait events. But just for illustration here, let's say there's a database type with just 4 wait events: CPU, read and write, and locks. You can see these different waits reflected in the active session requests. So if we not only count up the active sessions, but also count how many are there in each wait state, this means that we can build a very nice visualization, something like this. A visualization that characterizes the prevalence of various wait events in a database's active sessions. This type of visualization is at the heart of performance insights. Keep in mind, we are still talking about database load. That key core metric can tell you when a database is having performance issues. And the wait event breakdown can tell you why it is having performance issues. So now that we have a way of finding performance issues and also a way of understanding why we are having them, what's our first instinct? Well, my first instinct is to automate it. At AWS, we automate to reduce our customers' operational burden. And we also heard our customers loud and clear telling us that they didn't want to have to browse around in performance insights, looking for problems and analyzing wait events manually. They wanted specific analysis and prescriptive advice. So we got to work. And so at reInvent this past year, we launched this brand new capability called DevOps Guru for RDS. Now, for a long time, customers have been telling us that they like a lot of things about performance insights and CloudWatch, which let them explore all kinds of issues around database performance and troubleshooting. But customers have also told us loud and clear that they would like a little more help tracking down potential problems and, even more importantly, figuring out what to do about them. This is where DevOps Guru comes in. Since its release in May of 2021, DevOps Guru has been helping customers by telling them about unusual and problematic performance behavior throughout their application stack. We are now raising the bar for database diagnostics, bringing detailed database-specific capabilities to DevOps Guru. DevOps Guru for RDS goes several steps further than performance insights by using machine learning to detect and diagnose performance problems in your databases in order to help you fix those problems very quickly. Let's jump right in and take a look at what this new capability can do. So DevOps Guru for RDS uses machine learning and anomaly detection to look for unusual and problematic performance events in your databases. When it finds one, it performs analysis on the anomaly to determine what kinds of conditions are contributing to it. Just some of the conditions that DevOps Guru can highlight are database wait states, also known as wait events that are creating bottlenecks for users. The top SQL commands that are being sent to the database by the application and that are contributing chiefly to the anomaly. Any other notable metrics like memory pressure and I/O that might also be contributing. Finally, DevOps Guru for RDS suggests what you can do next to address the issue. Let's take a moment to highlight a few key things about this new capability that we think make it particularly useful for developers and database folks. First of all, DevOps Guru for RDS monitors for anomalies using that special metric called database load. As we've discussed, this metric registers any kind of database contention across every possible type of bottleneck. Our anomaly detection uses a database's metrics history to look back in time and establish a baseline workload pattern. Then it zeroes in on significant deviations from that pattern. This provides a much more accurate and relevant set of findings than, say, conventional static monitoring thresholds, which typically can be very noisy and can overload operators with alerts and alarms for things that aren't typically problems. So DevOps Guru for RDS analyzes these anomalies, pulls them apart, and identifies causes based on algorithms developed from years of performance analysis at Amazon across thousands and thousands of databases. To you as a customer, you clearly benefit from these explanations of the results of this analysis, as well as you're very quickly able to find the heaviest hitting bottlenecks on your database clusters. Once you find them, DevOps Guru for RDS provides clear next steps for what you can do about them. I think we should pause for a minute just to explain what DevOps Guru is and how DevOps Guru for RDS adds to it. DevOps Guru is a service that's been available on AWS since a while. It looks across your whole application stack for problematic behavior and tells you what's going on. DevOps Guru already includes RDS and Aurora in their analysis, but up to now, it hasn't included a database deep dive. So DevOps Guru for RDS adds a few special things to raise the bar in DevOps Guru. First of all, it fine-tunes anomaly detection for Aurora to accommodate the particular workload patterns of relational databases. Then, as we have mentioned before, it shows the customer the results of a database-specific analysis and recommendation process. So here's a breakdown of how this new capability functions. It all starts with performance insights, the database tuning, metrics, and telemetry tool for RDS and Aurora. DevOps Guru for RDS relies on this data and only works if you have performance insights enabled on your Aurora clusters. DevOps Guru for RDS then ingests these numeric metrics only. Note that it will never ingest any customer SQL commands or any other sensitive data. It particularly monitors the database load metric for anomalies, comparing historical baselines to current activity to pinpoint unusual behavior. One of the optimizations DevOps Guru for RDS has made for database workloads is to account for seasonality. In many database workloads, there are regular periodic spikes of activity from, say, batch jobs or ETL jobs, reporting, and other scheduled tasks. DevOps Guru for RDS only highlights anomalies that are not periodic and that occur outside of the regular course of normal database activity. Once an anomaly is detected, DevOps Guru for RDS performs analysis on the metrics that make up the anomaly, making note of the most prevalent wait states, SQL commands, and other metrics that coincide with the anomaly. A rule-based algorithm then processes these results and generates and stores a simple, straightforward explanation and recommendations. DevOps Guru for RDS sends the basic anomaly information, including severity, time frame, and resource IDs to the main DevOps Guru service console. And then DevOps Guru has the ability to also send SNS events and integrates any database anomalies into the big picture of your full application stack. Here in the DevOps Guru console is where customers usually first find out about a database anomaly. Anytime DevOps Guru for RDS has detected an anomaly in an Aurora cluster, the DevOps Guru console will highlight it and direct you to the DevOps Guru for RDS detail page for that anomaly. On that detail page, DevOps Guru for RDS displays the analysis results, providing the context necessary to understand what is contributing to the database issue, and more importantly, also the results of the analysis that point you to the best next steps for resolving the problem. Now that I've had a chance to introduce you to the feature, let's talk a little bit about how to get it working. As I mentioned, DevOps Guru for RDS is part of DevOps Guru. And that means to use it, you have to turn DevOps Guru on for your application stack or the account. You can find DevOps Guru on the AWS console under Machine Learning. Once you click there, if you haven't enabled DevOps Guru for your account, you'll just arrive here. On this page, just click Get Started. On the Getting Started page, you can learn a little more about DevOps Guru and also see the permissions that the service needs in order to do its job. Scrolling down, you can see and choose which resources in your account you want DevOps Guru to monitor. You can choose to enable all the resources in your account, or if you click Choose Later, you can later select any resources with a particular tag or a particular CloudFormation stack. Remember, DevOps Guru monitors your whole application. So enabling by tag or a CloudFormation stack helps it differentiate one application from another. Here, you can also set up SNS to receive alerts when DevOps Guru detects something is happening in your environment. Once you've made your choices, just click Enable. When you first enable DevOps Guru, it needs some time to establish a baseline and begin detecting unusual patterns. You could start seeing insights in as soon as 2 hours after enabling it, depending on the size of the account, and of course, whether something anomalous is happening. This dashboard will give you a summary across all your monitored resources. Once DevOps Guru begins detecting things, you will find everything listed in the Insights page. The individual insights have names that are indicative of one or more anomalous metric that DevOps Guru detected. And if you click into an insight, it shows you the insight detail page. With respect to RDS, any given insight in DevOps Guru may or may not have an Aurora component. In this example, we have a few Lambda errors and a RDS DB load anomaly. On the insight detail page, from the top, you'll find things like insight severity, start and end times of the insight, and the status of the anomaly. In this example, you'll notice this is an ongoing anomaly, so you'll see the status as ongoing. You can also see aggregated metrics that DevOps Guru detected that were anomalous at the same time. Now, this paints a picture of the overall issue to help you understand the full extent and possible origins of an issue in your app stack. Looking at this particular example, we have some anomalous metrics from RDS and Lambda. You will also see that there is a special button on the RDS metric finding inviting you to view the detailed analysis. This is your indication that DevOps Guru for RDS has been triggered and a deep analysis of the database component of this insight is available. Below the aggregated metrics section, you'll find some relevant events distributed either over a timeline view or a tabular view. Things like infrastructure events that may happen during the anomaly, like auto-scaling activity, etc., that occurred on your app stack during this anomaly that DevOps Guru used to generate these insights. The primary metric section summarizes the DB anomaly, which is the top-level anomaly within the insight. You can think of this anomaly as the general problem that is experienced by your database instance. Finally, you'll see the analysis and recommendation section, which describes a specific finding that requires investigation. Each finding corresponds to a set of related metrics. And also conveniently linked here, you will find our brand new documentation, which provides diagnostic guidelines for each of these wait events. You'll notice for this example here, there's also a SQL ID. And if you hover over the SQL ID, it shows you the actual SQL statement. Clicking on this SQL ID will in fact take you to a view in Performance Insights dashboard that shows the details and history of the SQL statement itself. Now, in addition to the DevOps Guru console, you can also get a glimpse of an ongoing anomaly or the RDS dashboard. In this case, it's the APG1 instance, 1 DB instance in our Aurora Postgres cluster that is seeing an increased database load of 272 times above normal that likely impacted our application performance. Drilling down further, we will see that the anomaly is also visible in the Performance Insights dashboard and is highlighted as a high severity anomaly in the DB load graph. In this dashboard, you can also see the top SQL queries in the top SQL view below that might be contributing to the relevant anomaly. And with that, I would like to invite my colleague Maxim to take over and walk through a demo of the kinds of findings and advice you can expect from DevOps Guru for RDS.
In this demo, we're going to look at two separate scenarios to see how DevOps Guru can help you troubleshoot performance issues in your applications. Now, to set things up, for these scenarios, we'll consider a case of an online bookstore. This bookstore is selling books via its website out of its warehouse. And as any online business, it runs a number of applications to support its operations. And of course, whenever there is a production software environment, there is also a support engineer who is tasked to monitor that environment, react to problems, and address the various issues. One day, that on-call engineer receives a notification from DevOps Guru that tells her that a major performance anomaly is happening with one of their applications. So let's take a look at this case and see how DevOps Guru can help troubleshoot this particular issue. So the first thing that we're going to see is the overall application dashboard. So in this case, we can see that there is a single unhealthy application called Inventory Tracker. And we actually have several different applications, but most of them are healthy. But one of them is experiencing ongoing performance issue. Now, if you're wondering about how to define these applications, there are several ways to do it. You can either use CloudFormation stacks that ties all of the resources together in a single application, or you can use special tags that you can assign to different groups of resources to mark what represents a particular application. But going back, there is currently an ongoing issue with the application called Inventory Tracker. So let's take a look at exactly what is going on there. So here we can see that there is a single ongoing anomaly with high severity that started at 12:19 UTC. If I click on the link for that anomaly, we are going to see the main DevOps Guru finding. And I'm just going to briefly comment on what exactly you're seeing and how exactly DevOps Guru identified that there is an ongoing performance issue. Well, as you can see here, there is a number of metrics that DevOps Guru found that they experience anomalous behavior. Now, here you can see that there are 5 different metrics that are spread across 2 different types of resources. So there is an RDS database, and there's also a Lambda function. And DevOps Guru shows you the exact timeline of when anomaly was detected, right? Or here, separately for each metric. And you can also see the graphed anomalies. And these graphs will give you a more precise picture of what exactly the problematic behavior of these metrics look like. But going back to the main screen, here, looking at these metrics, we can confirm that our application, which in this case represented by Lambda 8 function, is indeed having some serious issues. So we can take a look at its metrics in detail and see that the duration of this function or estimated time to run for this function has increased dramatically. And also this function is now throwing quite a few errors. So it's definitely in a bad shape. Now, of course, this Lambda function is not the only part of the application. In a modern world, applications are typically built in a distributed fashion where different pieces of business logic are assigned across multiple different tiers. And when you investigate performance issues, the first question that people typically ask is, well, which tiers in my application stack are actually responsible for the problem? And here, DevOps Guru has given us the first important clue. Because in this picture, we not only see that the Lambda function is having an issue, but also that the database instance that is a part of this application stack is having a correlated issue. So a performance issue that happens at the same time. Because we know that our Lambda function issues frequent calls to the backend database, this is an important observation. So here we actually can make a connection that these two problems are likely related. And in fact, if you want to find out the real root cause of this problem, you probably have to look at the database, just because it's downstream. Well, the good news is DevOps Guru has a dedicated component that can do a deep dive on the database level, run analysis on what's going on with the database performance, and report results back. In this case, this analysis has already been run and completed, and its findings were linked to the main DevOps Guru finding, and we can access them here. Now, let's click on View Analysis button and see what exactly are the issues with the database. Here is the database-centric view of this particular performance issue. And there are several pieces of important information here. First of all, we can see that there is a pretty significant spike of database load measured in average active sessions, so something my colleague has mentioned before. And to put it very simply, this spike means that there are a lot of database users or sessions who are currently executing database calls and are waiting for the database to respond back. And these waits are quite long at this moment, which is why we are having this performance issue, and which is why the database at the moment is considered to be unhealthy. If we look at the spike, we can notice that the spike is large in both the absolute values, right? So we have the 1,400 average active sessions at the top of the spike, and the normal number of average active sessions for this database should be less than 2, which is represented by the number of vCPUs here. But also the spike is very unusual. As we can see here, the typical database workload is around 0 average active sessions. In other words, this database is typically very idle. But in this case, we can see that the spike is actually more than 1,000 times higher than the typical database workload activity. So this makes it a very unusual spike. Well, in any case, the large and unusual spike represents a very acute and severe performance issue that we are observing on the database level. But why exactly are we seeing this problem? What's going on with the database? And here is where analysis part of DevOps Guru for RDS comes in. So we can look at the analysis section, and as a big picture, essentially what we're seeing here is that the database is experiencing a heavy database lock-in conditions. Now, just to step back a little, lock-in conditions is one of those things that are very hard to detect using quote-unquote traditional monitoring approaches. For example, many organizations rely on resource-based monitoring, such as CPU utilization, for example. And just to give you a sense of why CPU utilization is not the best metric to detect this particular type of problem, we are going to take a quick look at CPU utilization that is measured on this database. So here we see that the way that CPU utilization has been unfolding over the last 3 hours. And there is definitely an increase, which is correlated to the type of the problem. But even at the peak, as you can see, the maximum CPU utilization is just 35%. And this number is usually too low to trigger any actionable alarms out of that. In other words, if you watch CPU utilization, you'll probably miss that particular issue. And that's why relying on a database load metric is better. And that's why we've chosen a database load metric as our main metric. But going back to our case. So the database has been experiencing lock-in conditions. But what kind of lock-in? Well, the DevOps Guru for RDS has determined that as well. So there is a particular type of database lock-in called lock tuple that is currently occurring in our database. And we know that it's lock tuple because it's the wait event, once again, that my colleague has mentioned before, that is dominating this particular spike of database load. And lock tuple sounds a little bit cryptic, and we, of course, recognize that fact. And that's why in DevOps Guru, you can click on the wait event name and see the simplified description of what is really going on with the database. And it looks like in this case, we have a situation where there are multiple concurrent database sessions that are competing for the same exact database records. So that's easy to understand. Now, we can also see the actual SQL that is mainly participating in that competition. So in other words, the SQL is a likely culprit for the problem that we're seeing. Okay, so now we understand the problem in a little more detail, but what can we do to actually solve it? How can we address the problem and make sure that we no longer see this database lock-in issue? And that's where troubleshooting documentation comes in. So here at RDS, we've looked at the typical wait events that are occurring in our fleet, and we've created detailed troubleshooting guides for all of these events. And these guides are part of regular Aurora documentation now, and the way that they are structured is that there is usually a section that describes the likely causes of increased weights, as well as the action items that you can take to troubleshoot and address them. And these action items frequently include the actual code references or SQL queries that you can just copy and paste and run. So for example, in this case, we can refer to one of the documents that describes how to troubleshoot lock-in scenarios. We can copy the recommended view SQL that is provided in these documents. And we are going to query the blocking tree to see what is the root cause of this particular issue. So in this case, you can notice that there is a single session that is holding the entire tree. So we know where the session is coming from. We know which statement the session is running. And we also know which particular database record the session is competing on. And everybody else is waiting for this session to unblock this record. So essentially, if we just kill that one particular session, that would address this particular performance problem. So it's as simple as that. All right. So going back, just to summarize what we've seen in this example. So DevOps Guru for RDS first recognize performance issue that is pretty hard to detect. It also established an important connection between application issue and the database issue and directed us towards analyzing database performance because it was the most likely culprit. On the database level, it discovered the nature of the database issue that was going on and also explained why this issue was happening. Why did we see those logs and what types of logs we saw? It highlighted the SQL that was likely the main contributor to the problem. And finally, it provided detailed troubleshooting guidelines to address this problem at its root cause. So these issues are happening in the real world quite frequently, and they usually take some time to resolve, but hopefully with the help of DevOps Guru, the time to resolution can be a little bit faster. All right, so I'm going to switch gears and look at one more scenario. So the nice thing about DevOps Guru is that you don't necessarily need to be on the system when a performance incident is going on. DevOps Guru captures and records all of the performance incidents, and it maintains a historical record of them. So essentially, you can always go back to the past incident to investigate the issue that happened some time ago, maybe because of the customer request to see what was going on yesterday at 1 p.m. So let's take a look at one of those incidents that happened in the past. So here you can see that there is a history of different anomalies that happen with different applications. So let's look at one of the particular anomalies that happened a couple of days ago with the shipping application. Now, when we look at the main anomaly screen, we can see a very similar picture to the first example. So there is a number of metrics, and DevOps Guru detected anomalies in those metrics, and we can see the exact timeline of anomalies and also the graph representation of anomalies. And also, just like in the first case, DevOps Guru combined anomalies from two different resources, the Lambda function, or quote unquote, the front end of our application, and the database, or quote unquote, the back end of our application. And because we see those two resources in the same anomaly, and because we know that our Lambda function actually frequently queries that particular database, we can reasonably infer that, once again, the database is likely the root cause of that issue. And if we want to find out what's going on, we need to look at the database. Now, there is one thing that is interesting here. We actually have detected anomalies on more metrics. And one of those metrics is called disk queue depth. It is happening on the database resource. And because we see anomaly on this metric, we can reasonably conclude that the actual problem is likely related to I/O. But let's confirm that. So if we click on the View Analysis button, we can see the database-centric view of this performance issue. And if we look at the main graph, we can confirm that this particular performance issue is indeed related to I/O, because the most dominating weight event that we see is I/O exact sync, or I/O related. So if we look at the analysis, we once again can pinpoint the actual SQL that experienced those I/O issues, and also the simplified description of the problem, what exactly is happening on the I/O. And it looks like in this case, what is happening is that there is something related to commits, perhaps the increased number of commits. We can corroborate that theory by looking through the troubleshooting documentation. If we open the link and read the likely causes of increased weights and suggested action items, one of the action items is actually to reduce the number of commits. And this is probably the most typical case for this particular type of problem. Now, there's one thing that I haven't mentioned yet, that a very nice feature that DevOps Guru provides. And this is the timeline of events that it captures. Now, whenever you investigate a performance issue, it's really important to see whether there was something in the environment, configuration, or perhaps your code that changed very recently. In other words, if you see, for example, that a particular database parameter or particular piece of code was changed right prior to the time when anomaly has actually started, it's very likely that there is a causal relationship between them. In other words, you change the database parameter, and that probably triggered the anomaly. Now, let's look at the timeline for this particular incident. And here we can see that right prior to the anomaly start, there was actually a change in code, which in our case is probably important. So the action item here would be to look at that piece of code and find out why exactly it made the application issue more commits. And that's something that we can do. I hope that these two examples showed you that DevOps Guru and DevOps Guru for RDS are useful tools that can help you troubleshoot performance issues better and faster. And as a side note, I'd like to say that we are constantly working on improving these tools, and we want to make them even more useful in the future. So please keep watching the space. Thank you.
Thanks, Maxim. Those are some great examples of the kinds of insights DevOps Guru for RDS can provide. Now, let's talk a little bit about pricing. So DevOps Guru for RDS is offered at no additional charge as part of the existing price that DevOps Guru charges you for analyzing Amazon RDS resources. DevOps Guru segments the resource types it evaluates into two groups. Group A, which consists of Lambda and S3, and Group B, which consists of Amazon RDS, EC2, Redshift clusters, and 25 other AWS resource types. You will also notice that Group A and Group B both are priced very, very economically, where Group A actually equates to approximately $2 per resource for a month, and Group B equates to approximately $3 per resource for a month. If you choose to, you can also opt to use tags to control costs by enabling DevOps Guru only for your Aurora resources. For more information about using AWS tags with DevOps Guru, please visit the topic Working with Resource Tags in our documentation page. So, to summarize, today we didn't only want to tell you about this great new capability called DevOps Guru for RDS, but we also wanted to provide you with some foundational knowledge that you could use and that could help you understand why it matters to find and resolve these performance disruptions. Amazon RDS and Amazon Aurora are designed to take care of the complicated parts of running a database. But performance issues are a complicated part. And until recently, we only had performance insights to help you shine a ray of light onto that topic. But now we have DevOps Guru for RDS. Using machine learning and all of our experience managing a fleet of Amazon databases, we are going one step further towards making performance management an automated part of our managed database service. We would encourage you to leverage these helpful resources, which will help you to learn more about DevOps Guru for RDS. So with that, I want to thank Maxim. I want to thank all of you for attending and paying attention to this talk as we explained this brand new capability called DevOps Guru for RDS. Take care, stay safe, and have a great rest of your day.